this video, we're going to study net of reinsurance data versus gross data, and show that the net of reinsurance data actually, and in terms of reserve distribution, has a high coefficient of variation than the gross, and explain exactly what happens. That might be an indication that the outward reinsurance program isn't really working so well. In other words, in terms of capital, it's a percentage of the mean risk capital. It's a percentage of the mean. You probably need more for the net data. So let's, and I think we've seen this phenomenon in a different study. Let's open comp, go to the composite data sets on the top of TG and open comp N and G, and go to related data sets and run. There's a lot of extraneous models here we don't really need, but run good one constraint for each. I've been playing around a little bit with this, and that's why the extraneous model. So let's run good one constraint with each. Oops, if I open, it actually sends an error message, because you'd see that for FAC and G, I've actually highlighted two models, so two data sets. So I need to only highlight one for each. So let me get rid of this before optimize. Okay, so let's open that now. And tile vertically, minimize regression tables, and for the gross data, you've got a positive trend, and for the net data, you've got a slightly positive, but there's also an outlier sitting here at the bottom, so let's get rid of that. Now I want to set that trend to 0. It's a tiny trend, 0.0030. And I guess one way I could do that is just click on the optimize once for the individual data set. Okay. Now, we don't really want to change much of the structure of the model. And you can see the model structure for each net and gross is very similar. Okay, we've got a trend here that's not significant. What's the correlations? Process correlation is very high. You can actually see that in the residuals, 0.84. If you look at the residuals versus calendar year, for instance, if you look now at the net, they're very highly correlated. Okay, now you can leave the model as it is, or you could, for instance, reinstate only alpha parameters, because you don't really want to change the structure of the whole model. So let's suppose we, the other thing you don't really want to do, if you look at the parameters versus calendar year, you don't want to credibility adjust to 6.5% with the net, which is essentially 0. I don't really want to do that. I don't want to make those two trends equal. I guess if I do, they might both go to 0. So I don't really want to do that. So I only reinstate, say, the alpha parameters, only alpha parameters, because they're all varying parameter. Reinstate only alpha parameters. And we've done that for both data sets and re-estimated the model. So when you click with the right button either on the model display or the residual graph, when you reinstate on the alpha parameters or reinstate all parameters, you're reinstating them and estimating. Okay, so now click on the double O to optimize also between data sets, and you can see that this development trend has been set to be the same. Okay, and then we've got these lines which represent the bars. If we had a bar there, a red bar, you'd say that this trend was the same between the two data sets. But having this line here says the alpha level is the same. For instance, the alpha level here is the same for the two data sets. Let's move this up a bit. What we're saying from this that the period 97 to 98 for the gross is the same level as 90 to 92. I don't really know whether that necessarily kind of makes any sense. Statistically, it might be the same. I don't think it kind of makes any sense in terms of the business. I mean, one would have to look at the reinsurance program, why those levels might be the same. If you feel due to your business knowledge about the outward reinsurance, you can remove that particular constraint, but it's a level constraint, okay? All right, now, in terms of inflation, it seems like the 4.8% for the gross, if you now look at the residuals, they look pretty stable. So, you know, both for the gross and net data, if you were doing the auto validation for the individual base triangle group, or base data set, you'll find that, you know, removing the last 4 years, statistically you get the same answers. But again, if you compare the two trends, the gross is growing, the net is not. So one could argue that the part that's growing is being reinsured. However, when you do a forecast, okay, and you look at the forecast summary, you'll see that go to the gross data, FAC-ENG gross, the coefficient of variation is 14%, yet with the net data, the coefficient of variation is 15%. So, you know, the risk capital allocation, let's save this model. What shall we save it? Let's just call it optimal training. Save. Now, if I now just forecast for the gross, and then I load the model in the same window, in a new window, load model in new window, downward arrow here, optimal training, do a forecast. I now do the forecast, I think, for the net. And tile vertically forecast summary. Sorry, open the forecast summary, right button of your mouse on FS all. Now tile vertically, minimize other types. 15%, 14%, the coefficient of variation, not that much difference. For the gross, it's 14. For the net, it's 15. Well, it's not lower, let's put it this way. Why isn't it lower? I mean, if you look at the model display, you'll find that the gross has lower process variability. If you look at this, for the gross, it's around 0.55, then drops. For the net, it starts at over 0.7. So the net data actually has more process variability than the gross data, okay? But it doesn't have the uncertainty in the trend going forward along the calendar years. It's got zero trend. And those two effects are compounded so that if we go back to the forecast summaries, the coefficient of variation, minimize other types, the coefficient of variation of the net reserves is slightly larger than the gross. If you do PALD for both to find out the percentage capital you need at the particular VAR as a percentage of the mean, I think those should be about the same, or maybe the net a little bit higher. So with the right button of your mouse on the PILD, predictive aggregate loss distributions, we are finding the distributions of aggregates of log normals, 10,000 simulations on each. Okay, ICRFS detected 0-month forecast for calendar period 2017. Please exclude above periods from the forecast before running PILD. Well, let's check that, okay? It's a nice, interesting error message. What does it all mean? So let's cancel. So what I'd like you to do is open the forecast tables. forecast tables all, tile vertically, minimize other types. If you scroll down, you'll see that the last year is actually run off. There's no data there. We get zero forecast. We set the exposure to be very close to zero relative to the other years. And that year's actually run off. So there's no need for us to forecast for that year. So let's do the forecasting again. This is a good exercise. With the right button of your mouse, click on all. And now go to periods. And only forecast, so reserving periods, last accident period is 2001. Okay? Do the same thing in the other one. Periods, 2001. Okay? Now do the PILD. And again, tile vertically, minimize other types, and let's look at our risk capital as a percentage of the mean, top right, say at the 95th percent. On the right side, risk capital, that's our 95% VAR. The gross is, if you point to it's 24.7%, the net is 26%. So you need a bit more capital for the net. So one would have to go back and study the reinsurance arrangements, the outward reinsurance arrangements, and try and figure out why isn't that really working for. Unless, of course, they got a very good premium. Incidentally, if we go back to the model with the right button of the mouse, always actually you don't have to. Both models are the same in each run. So anyway, just click on model display. If you wanted to remove these level constraints between, you just click there and then click on remove cross data set alphas. Click there, estimate and close. And then you might decide, well, I'll use that one, this particular model. But even if you do that, you'll get the same kind of phenomena about the gross has a coefficient of variation which is maybe slightly less than the net. But most of that actually is driven by the fact that the gross has, if you look at the process variance, process variability in the model display for the gross, it's less than the net. And that's something we can't change. Well, we can. I mean, when we forecast going forward, we can make it zero if we want to. But I don't think it's a good idea.